Hey everyone, welcome back. We're going to continue now onto 5.4, graphs of sine and cosine functions. The essential question for today is, how do I graph sine and cosine functions, as well as any stretchings, shrinkings, frequency changes, and or translations applied to them. So we're going to be looking at the graphs of both sine and cosine functions in this section. For today's notes, we're only going to work on cosine. But anything that we do for cosine, it will work for sine as well. Just know that they are going to be different graphs. First thing I want to actually look at before we even copy anything down, so again, don't copy this down, are some basic definitions. So this is in the book for those of you who have it. And what I want to look here is that right here, there's the word sine curve. And this defines this portion because what we're looking at is a graph to represent the sine and cosine functions. All right? The black area versus the gray area represents one period or one cycle of it. And for each of the sine and cosine functions, a single period consists of 0 to 2 pi. So the period here is defined as 2 pi. What we mean by a period is that actually what you see here is that it's going to repeat from this point all the way here. It's completely different in terms of its curvature. But then once we reach this point, it ends up repeating what it did over there. So which is why the period is 2 pi, and that's what we're going to be looking at for every single example besides a couple. All right? So let's go ahead and move on then. Actually, before we even do that, you're going to copy down these guys, the library of parent functions, sine and cosine functions. So go ahead and copy down all of this information, pause the video now, and although you are going to be sketching it right here, the cosine curve, we're also going to show you how the cosine curve is sketched in the first place, and we're going to do that using the unit circle. So again, pause this if you need to, write down all of that information. All of this information will be necessary as we take these functions and apply shifting, stretching, shrinking, etc., etc. Okay, so let's go ahead and move on then. With a unit circle, we need to be able to understand by now how to take sine of 2 pi, pi over 2, pi, 3 pi over 2, all of those. It's going to be really critical that we remember all of that, because not only will it help us answer those kind of questions faster, it's also important in terms of graphing. So again, today we're going to be focusing on the cosine curve. So let's go ahead and find the cosine of 0. That's going to be x over r. Just like before, our x value is 1. Our radius is also 1. So the cosine of 0 is 1. And then let's go ahead and do the rest of them. Cosine of pi over 2. 0 over 1, 0. Cosine of pi will be negative 1. And cosine of 3 pi over 2 is 0. Then we go back to 2 pi, same as 0. It's going to be 1. All right, now that I know this, I'm going to go ahead and draw in the basic cosine curve. So f of x equals cosine x. If you're wondering why I'm using x instead of theta, it's because when we refer to functions, we use function notation fx so that there's some consistency when we're talking about other types of functions. So don't stress out too much about that. We're going to be looking mainly at the period of 2 pi, and all of my examples are going to be focused in the area of 0 to 2 pi. But just know that the cosine and sine curves do go on and on forever, just as they looked in the picture. So here at 0, then I have pi over 2, pi, 3 pi over 2, and 2 pi. Right, so at 0, I do have 1, and let's go ahead and outline that, 0, 1, and negative 1. So at 0, I have 1. Pi over 2, I have 0. Pi, I have negative 1. 3 pi over 2, I have 0. And 2 pi, I have 1. Sketch in that curve real quick. And that is the curve for a cosine function. Now note that once right here, that's actually the highest point for the range. It's going to go back down, and over here it will go back down as well. So again, I could continue sketching this, but I'm going to restrict my domain for all of these to 0 to 2 pi, just to keep it simpler. All right, let's go ahead and move on then to example 1. Actually, yeah, example 1, where we're going to be looking at amplification. So we're going to be looking at stretches or shrinks. And before we even do that, you are going to copy another thing for me. Go ahead, look right here, and copy down the definition of amplitude of sine and cosine functions, or sine and cosine curves. So amplitude is basically the number that we're going to multiply the sine and cosine curves by, basically stretching them or shrinking them by some number. Okay, so we're going to look at the example of y equals 2 cosine x. So nothing else, just an amplification. We have 2. So it's basically going to stretch this original cosine curve all up by 2. If I were to rewrite all of these data points over here as coordinate points, so I have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi 1. That actually helps me a lot faster when trying to figure out these guys. When I plug in 0, I still get cosine of 0, and that would be 1. 1 times 2, though, will give me 2. So what I'm really doing is I'm multiplying all of my y values by 2. So let's go ahead and quickly jot those down as coordinate points. Pi over 2, 0, pi, negative 1 times 2 will be negative 2. Again, I'm just looking at these numbers up here, my coordinate points for my original parent function. 0, and then 2 pi, 2. Okay, so I'm going to sketch that in real quick. There's 0 right there. 1, 2, 1, 2. Then we have pi over 2, pi, 3 pi over 2, 2 pi. Whenever we talk about a certain period, we always split it into sections of 4, because that's going to help us with our main calculations. And when we're talking about the unit circle, we're always talking about these 4 major points anyway. So it's going to make it really easy if we split them into these 4 parts. Right? So at 0, we have 2. Pi over 2, we have 0. Pi, we have negative 2, 0, and 2. So, same, pretty much similar curve, just stretched up by 2. Right? So if you multiply by a number bigger than 1, you're going to be stretching it. If you multiply by a number smaller than 1, then you're going to be shrinking it. Right? So there's amplification. Moving on now, we have example 2, where we're going to be looking at frequency change. Frequency change is a bit different, and the book calls it a horizontal stretch or shrink. And let's go ahead and first write down this definition, or this formula. So period of sine and cosine functions, where b is a positive real number, the period of all of that is given by period equals 2 pi divided by b. So b is that number that we're going to be multiplying x by. And that's going to basically affect how long our frequency is, or how big our period is. The period earlier for all of the sine and cosine curves were 2 pi. Which is why that formula, period, equals 2 pi over b, uses 2 pi. Because the sine and cosine curves have a period of 2 pi. But if it's affected in any way, then we got to divide it using this number. So, in my example, I'm going to be looking at y equals cosine of x over 2. I'm going to rewrite this so that I actually have a b value. That's going to be cosine half of x. Okay? So in this problem, half would be my b value, which means I'm going to figure out that my period is 2 pi over 1/2, and that's going to be 4 pi. So instead of a period of only 2 pi, my curve is now going to stretch all the way from 0 to 4 pi. Now, one way we could split this up into our 4 sections is just to divide by 4. And honestly, that's going to be the easiest way. So, let's go ahead and sketch in this curve real quick. We're not doing any vertical vertical shifts because this is all just stretching it along the x-axis. So, over at 0, we still have a value of 1. We don't actually hit 0 until we hit 2 pi. Pi, sorry. Let me sketch this in real quick. There we go. All right. So over here, this is still our starting point, but we don't actually move to the next point, and I think the easiest way I can show it is over here. So this is the original parent, and what's going to happen is that basically everything's going to be bumped up a bit. We're no longer going to be 0 at pi over 2, because what's happening is that if I were to create kind of like an xy table for this one, x, y, and I were to plug in pi, this one would become cosine of 1/2 pi. This becomes my new cosine pi over 2 because my period now stretches all the way to 4 pi. So if I split up 4 pi into 4 regions, it's going to be pi, 2 pi, 3 pi, and 4 pi. Before, when it was 2 pi and I split it up into 4, 2 divided by 4 would be pi over 2. Then here would be pi, 3 pi over 2, and then 2 pi. Okay? So really all we're doing is dividing by 4 and using those numbers from there. So this is where all my numbers will go now. And as you can see, it's basically stretching along the x-axis. Okay? So same y values, just stretched along the x-axis. All right, final one, example 3. We're going to talk about translations, both horizontal and vertical. So here I have y equals 2 plus 3 cosine of x minus pi over 4. All right, before I do that, one final thing to copy. Sorry for all the stuff you have to copy today. Here are some key things that we need to look at. So there are going to be vertical and horizontal shifts. And basically in here where we have the minus c, that's going to tell us which way we need to go. If we have a minus, just like before in our previous translations, that's going to be a shift to the right. All right? So I'm going to go ahead and break this apart, and I'm going to look at this component first. So 3 cosine x minus pi over 4. I know the parent function of cosine x is this lovely curve. But what this negative pi over 4 tells me to do is actually shift to the right by pi over 4. This 3 from before is actually an amplify or stretch by 3. And then finally, this one comes last. We shift the entire graph or function up by 2. All right, so my video is unfortunately running long. I will put a picture into the description box, so please click that, and you're going to see what this translation should look like. All right, so have a good day, you guys.